Have you ever wanted to go back in time and recreate the past? Well, with slowly changing dimensional tables, you can do just that. Hi, I'm Brian Amrine with Value Driven Analytics, bringing you today a topic that was recommended by a commenter on our SQL rank function video. As a data scientist, I frequently ran into situations where I needed to recreate feature variables as of a particular date, usually a date of prediction, in order to avoid data leakage in my data science models. So I couldn't just go to a table and pull the current value for those feature variables, because it was possible that the value had changed and would have been different when the model had been ran for the purpose of prediction. In these situations, it is very helpful to have access not just to a current table, but also a slowly changing dimensional table. With a slowly changing dimensional table, you can recreate feature variables as of any date you like. We'll start today's video by talking about some simple ways that you can start to build your own slowly changing dimensional table. And then we'll talk about how you can use a table like that to ultimately create feature variables as of a particular date. Slowly dimensional tables are all about preserving history. And when I think about this objective, I think about two different ways to achieve that. One would be to take a daily or perhaps even more frequent snapshot of a table or perhaps even an entire database. You could use Python or an ETL tool to pull all the records from a particular table of interest at the beginning or end of each day, then add a column to that table with a snapshot date, the date you're pulling the data, and then take the result of that and add it to your snapshot table, and do that every day. The benefit of this approach is it becomes very easy to pull feature variables as of a particular date. You simply filter your table using that snapshot date in the where statement to the particular date you want your feature variables to be as of. The downside of this approach is it could require a ton of storage space. You're essentially adding the size of your entire table or database every single day, every single time you take a snapshot. If you've got a really small table and perhaps you're just taking snapshots every month, this might be okay. But most of the time, you're going to want to build a slowly changing dimensional table instead. With a slowly changing dimensional table, you only add a record whenever a value in a particular column you want to track changes. When a value is updated in the original table, a record gets inserted into the slowly changing dimension table, with the row's ID, the column being updated, the column's new value, and the timestamp of the change. This could be added in real time, hourly, daily, or any other cadence that makes sense based on the business use case. You could use Python or an ETL tool to monitor the table in question, compare it to the most recent snapshot you've taken, then loop through all the columns of interest that you'd like to track, and for any cases where the value of that column has changed for a row, add a record to your slowly changing dimensional table. Finally, take the current version of the table and use that to update the last snapshot taken table for the next time you run this process. And schedule this process to run on whatever frequency makes sense for your business use case. Some systems might actually make updating a value in a source system automatically trigger the addition of a row to a slowly changing dimensional table. The benefit of this is it generally saves space compared to the snapshot approach we talked about first. If the values don't change, no new records get added to your slowly changing dimensional table. Whereas with the snapshot approach, that data is being replicated perhaps every day, even if nothing has changed in the table at all. With that being said, using a slowly changing dimensional table does add some complexity when you're writing SQL to code out what a feature variable's value was as of a particular date. But that's the subject of today's training video. So let's head over to SQL Server Management Studio. Here we are in SQL Server Management Studio, but this concept of slowly changing dimensional tables can apply to any SQL platform. Now today I'm going to be walking through this concept using a value-driven analytics database and a schema within that. The schema I'll be walking through, I've called it SCD illustration. very appropriately named. And we're going to be looking at just a few tables today. The first one is kind of our current snapshot table. We might just think about this as a typical table. And this one has a table of leads, people that we hope will buy a particular product. We track them in a table. And here I've created this table using this syntax. That's a training for another day. I've inserted some values into it. And let's just go ahead and take a quick look at what our simple table that we would use by default. One row per lead is what this table is going to be. And it's just called leads. So we'll do select star to select all the rows from that table. And as you can see, we have 3 leads here. We're calling the first one here, customer name is the first column, Sam, Brent, and Susan. We have a customer ID for each one of those leads or customers. The next column is current status. This represents at this point in time, and this table, let's say, is updated every day with what their current status is. Think about like a customer funnel. They might start with as a lead in our database who hasn't been contacted yet. That's what his state is right now. He's in the database, obviously, he has a row here, but he hasn't been contacted. Brent, on the other hand, at some point has been contacted. Today he's considered to be a contacted lead, but he hasn't converted yet. Susan, on the other hand, has been converted. She's in the database. At some point she's probably been contacted and her status has been updated to converted because she's bought something from this company. And we also have another column here just to illustrate the principle of slowly changing dimensional tables even more. This one can also change over time. It represents the last marketing channel. So the last marketing channel that Sam saw was social media. Brent last saw paid search. Susan last saw organic search. But you could imagine tomorrow Susan might see social media, perhaps for the first time, perhaps she's seen that before. And so this column would update to always reflect the most recent marketing channel that she's seen. And so these last 2 columns, you can understand how these could update. They're not going to update every day necessarily, but they could change over time. And so to perhaps create a data science model to understand how the current status and the last marketing channel perhaps impact their likelihood to convert to sale, we might want to recreate these variables as of a particular snapshot date when we're training our model. So that's the use case for today. Now, the next thing I want to walk you through is a slowly changing table around this. So here we've created a SCD illustration, a leads SCD table. And this time it's going to have the customer ID, the column value, and the date. So I've already created this, and then I've inserted some rows into it. And let's just take a look at what this looks like. Select all the rows, select star from our table. Okay, now remember our original table only had 3 rows. This has 10 rows in this case. So what's going on here? Well, perhaps we set up our slowly dimensional table to populate, and you can see the first date we have in the table is January 1st, 2024. So that's when we started collecting this information, for instance. And when we inserted the first leads into our table, we added rows here as well to say for customer ID 1, so we're doing this, we've got a row identifier essentially. Remember our previous table had an ID for each one of our customers, so this is how we can tie those together. For customer ID 1, which was Sam, the current status column is not contacted, and that got updated to not contacted to this value on January 1st, 2024. And also for that same customer ID, for that same row for Sam, his last marketing channel was updated to social media on the same day, January 1st. So this might have been the day that Sam even was put in our database. And you can see the same thing happened for customer ID 2, or Brent in this case. The record was created for him with a starting value for current status column of not contacted and a starting value for last marketing channel of social media as well. So these all happened on January 1st. There were essentially two records loaded, and your slowly changing table, in some cases, it might track all the columns in the table. In other cases, perhaps just certain ones that you are interested in tracking, maybe ones that frequently change or that are going to be used in a data science model, or where a historical snapshot might need to be recreated. So in this case, we're tracking current status and last marketing channel. Now, in this situation, I wanted to show an example of this. Perhaps Susan was not entered into the database until January 2nd. You can see a couple of rows here that update current status to not contacted and last marketing channel to organic search. For customer ID 3, these happened on January 2nd. So when a new row is inserted, in this case, the first two were put in on January 1st, Susan's put in on January 2nd, and so the date in our slowly changing dimensional table for Susan is January 2nd, the date that those records are being updated. In this case, it's the first time they've even been populating the table. But now something else happened on January 2nd. I'm looking at this row right here. This is for customer ID 2, so that's Brent. His current status got updated. Remember, his current status originally, when he was put into the database on January 1st, was not contacted. Well, now for customer ID 2, that current status on January 2nd is being updated to contacted. He was contacted on January 2nd. And so we've captured that in this change log. We see, okay, started not contacted on January 1st, updated to contacted on January 2nd. Very good. Let's see what happens next. Okay, on January 3rd, we had a couple updates. For Susan, customer ID 3, her current status is updated to contacted as well. She was contacted on the 3rd. So we have a record inserted to our slowly changing dimension table. And also on the 3rd, back to customer ID 2, Brent, his last marketing channel gets updated to paid search. Remember, he was originally put in our table on January 1st as with the last marketing channel of social media. Well, apparently he's seen a paid search ad now, and so that's being updated on January 3rd. And then finally, the last thing that happens in our slowly changing dimension table here is lead customer ID 3, Susan. She was put in the database on the 2nd. We see that here. She was contacted on the 3rd. We see that here. And now we see that her lead status, or her current status, has been updated again on the 4th to converted. She finally bought, and so a row gets inserted here as well. So that is our slowly changing dimensional table. Now I also have created here, I'll show you the code for it, a snapshot table. Here's a leads daily snapshot table. This is the first approach I was walking you through. It's really easy to recreate feature variables as of a particular date when you have a snapshot table, but again, it takes up a lot of space. So I've created this, I've inserted some rows into it. Let's take a look at what our snapshot table would look like here. Select star from. All right, let's take a look at what we've got here. Now, this table is basically identical from a column perspective to our original leads table. It has a customer name, a customer ID, current status, and last marketing channel, but it has one more column, the snapshot date. So what you'll notice here is the first two records are for Sam and Brent. Remember, based on our slowly changing dimension table, Susan, in this case, we're saying didn't get added till the 2nd, so she would not be in that snapshot for the 1st. When we pulled the data on the 1st, maybe at the end of the day, put it in our snapshot table, Susan did not exist in the database, and so there were only those two rows for Sam and Brent. But the next day, on the 2nd, when we run the snapshot, notice Susan is added. So that's one change we notice, and it aligns with our slowly changing dimension table. But the other thing that's changed as well is Brent has been contacted on the 2nd, and so his current status in the January 1st snapshot was not contacted, and now it's been updated to contacted. right? If that's what happened, if he was contacted on the 2nd and that was updated in the system this is pulling from, that's what our snapshot table would look like. And that's aligns with the row that we saw for Brent being contacted in our slowly changing dimension table as well. Well, then we have another set of 3 rows for Sam, Brent, and Susan on the 3rd. All the data is being recreated, and it's just being updated in a couple of places, right? So we saw in the slowly changing dimension table that Brent saw a paid search ad, and so his last marketing channel updated for these records associated with the snapshot taken on the 3rd. And Susan was contacted on the 3rd, so her current status column value has been updated from not contacted on the 2nd to contacted on the 3rd. And then finally on the 4th, everything is the same as the 3rd, except that Susan's current status value has been updated from contacted to converted. So you can see there's a lot of duplication happening in this table. When you just, if we were to count the total number of cells, for instance, here, in order to recreate a snapshot, there's 11 rows times 5 columns, so 55 cells of data. We could count the characters as well and really compare that to our slowly changing dimensional table. I think in this case we'd find that the slowly changing dimensional table requires less space. But watch how easy it is to see what our database looked like and get the features, the last marketing channel and the current status as of a particular date. All we have to do is just simply filter on the snapshot date, filter the snapshot date to be the date in question. So if we wanted to recreate these features, let's say we were trying to make a prediction as of the 2nd of who would convert, we would simply say snapshot date equals January 2nd. And we'll run this. Isn't that easy? So easy with a snapshot table. It's already done all the hard work for us of how to structure the data. But again, tends to take up a lot of space. So what if we wanted to recreate what the leads table looked like as of January 2nd with our slowly changing dimension table? Let's say we didn't have the snapshot table because it takes up so much space, but we need to recreate the snapshot because we want to get these features, current status and last marketing channel as of January 2nd. We have a slowly changing dimension table. Okay, it's taking up less space. Here's how we can do that. So what I would do is start with, I'll just start by selecting everything from our main table. So we'll start with the leads table. Just gonna copy this and again, leads table. I'll just run that, show you what that looks like. Okay, but these are the values as of, in this case, we're putting ourselves, it looks like the database would be updated through January 4th. So this is not going to work for us. This is the current values. This would have data leakage if we're trying to make a prediction on January 2nd. This has data from these current status and the last marketing channel, incorporate some data from January 3rd and 4th that we wouldn't have known about on the 2nd. And so we're going to resolve that. We're going to recreate that snapshot on January 2nd with the slowly changing dimensional tables. Now I'm going to start by doing a left join first. And essentially what we're going to do, there might be a way around this, but we're going to, for the variables we need to pull, which we're going to try to pull both of them, current status and last marketing channel, we're going to have to bring in our current status in one query and our last marketing channel in another. Again, there might be a way around that. But I'm using a subquery here, so that's why I have the open parentheses and close parentheses. I'll go ahead and give leads an alias of L, so space L, or you could say as L. Since we're going to be joining things, generally good to use aliases. And then I'm going to just do a select star for now. Select star from our slowly changing dimensional table, which is just leads underscore SCD. We'll just do select star for now to take a look at it. Okay, so the first thing I'm going to do to kind of refine this subquery is really, the first thing we're going to bring in is a particular column, the status column. And so the slowly changing dimension table can have values in it for multiple columns. There's a column that represents which column that change was for. So the first thing I'm going to do is filter on column equals current status. We're going to pull the values of, try to recreate the values of current status first. So I'll do that. I'll just run this for now so we can see what that looks like. All right, now we just have updates to the current status column. Another thing that we should do though is we're trying to recreate this as of end of day January 2nd, let's say. So maybe we're making a prediction for the 3rd. We should remove any updates that happened after that. So we're going to filter on the date variable, which is really like the change date in our slowly changing dimension table. So we'll say date is less than or equal to our particular snapshot date here, which is 2024-01-02. Now let's take a look at the results. Okay, great. We've got rid of all the updates that happened after the 2nd. We're not even going to be considering them. But we kind of have another problem here. You'll notice in some cases for customer ID 2 here, there's multiple values for current status. There was not contacted and contacted. How do we systematically determine which one to use? In this case, we'd want to use the latest one, the contacted for customer ID 2, but how do we do that systematically? This is a great use case for the rank variable. So I'm going to add to this rank, and we have a whole training on rank. Rank over, so it's rank, open parentheses, close parentheses, the keyword over, and then parentheses again. We're going to partition by, this is kind of where you want your rank to start over at. When a value changes in this column, I want you to just start the whole rank over. We need to get this subquery down to 1 row per lead, 1 row per customer, because that's what our leads table represents. So we want to join it on, we're ultimately going to join this subquery into our leads table on customer ID equals customer ID. So we need this subquery to be 1 row per customer ID. And so the purpose of this rank is to kind of deduplicate at the customer level. So we want the rank to kind of restart whenever there's a new customer. So in that case, what we want to partition by is the customer ID column. And then the next thing in our rank statement would be an order by statement. And we want to order by date, but we would want our rank to start with the latest date and then go higher from there. And so we will order by date descending so that the latest date will have a value of 1, which we're ultimately going to filter on later on here. So this is our ranking statement. We'll close it off with a closed parentheses. I'll just call this rank. And let's take a look at the result here. Okay, still 4 rows, but take a look at the rank column here. 3 of the values have a rank of 1, and 1 has a rank of 2. The one that has a rank of 2 here is for customer ID 2, and it's that not contacted status, the one that came first. So the ones that we want to keep all have a rank value of 1. So what we'll do here is now we're kind of moving on to the step where we join this subquery with the original table, the leads table. So we'll have our, with the subquery, we need to give an alias. So we'll alias this CS for current status. You usually want to give an alias that's a little more descriptive, or usually an abbreviation. We'll join on L.customerID, customer ID from the leads table that we've given an alias of L, equals CS, which is the alias for our subquery, customer ID. Okay, so that should work just fine. Yep, red squiggly lines went away. But there's one more thing we need to filter on. And if we were to put this in the where statement, it would automatically turn our subquery here into an inner join, which we may not want. In fact, right now we're setting up as a left join. So a way to avoid that, and really just make sure we join in the rows that we want to, is to add a filter within the join. So watch this. In addition to making sure that the customer ID from the leads table equals the customer ID from from our subquery, we're going to also make sure that the CS, our subquery, the rank field that we just created equals 1. So this is going to make sure that this row here, the original value for customer ID 2 that was later updated, that it's not brought in because its rank is not 1. Everything else, every other customer here will have a value. So let's update our select statement here too. We're going to select customer ID, as many things as possible that aren't changing from our main table, the leads table. So customer ID, we'll pull that from there. We'll also pull, I think we have a customer name field too. And I used A here, or we should use L. That's what the alias that I've given to the leads table. There we go. And then now from the CS subquery, we're going to be pulling in the column value. The column value column is what's going to have what we ultimately want to use for this recreated version of current status as of January 2nd. We'll just give it the same name, current status. Well, let's take a look at this query so far. All right, well, we still have one row per lead, so that's good. And then we'll check this current status against our snapshot table and see how it compares eventually as well. Now, we may want to do this as well for our last marketing channel. Perhaps that's another feature in our model that we need to recreate as of January 2nd. So we've done a lot of work here. I'm going to copy and paste it. The approach will be extremely similar. In this case, we're pulling from the same table. The column here, though, will change. In this case, we're going to be pulling from where column equals last marketing channel. You saw rows in our slowly changing dimensional table for that column as well. The same thing applies here. The snapshot date would be the same, and so we're saying date is less than January 2nd, 2024. Now there could be some more efficient ways to do this because you can see we've put that date in here twice. We could define a parameter at the top and reference the parameter. We could create a CTE at the top of our code that creates a filtered down version that automatically applies whatever that filter is. And then just from there, we'd reference that in both of these subqueries. And we wouldn't have to, at that point, have a date filter. We would have already done that in the CTE we created at the top. So several ways to maybe make this even more efficient by not having to list the snapshot date multiple times. But this way will work as well. So the only thing we're doing here is changing the fact that the column we're looking at this time is last marketing channel. And I'll just run the subquery here to see what this looks like. Now we're just getting the last marketing channel values. So we see, let's see here, social media, and organic search. Now in this case, we don't have any duplicates because there wasn't a change in last marketing channel until, I believe, the 3rd. Yes, our customer ID 2, their last marketing channel changed on the 3rd. So we really don't need the rank in this case, but we certainly could in the future. And so you want to prepare your data set, future-proof it. So we're already ready, set up for that with the rank variable creation and then filtering on that rank in our on statement. Now we need to give this a different alias. We'll call this perhaps LMC for last marketing channel. And this is going to be really easy to pull in that last marketing channel since we've already done this for current status. We're still going to pull in the column value, but we're just going to pull in the column value from this LMC, this last marketing channel subquery, the second subquery here that we just created. And that will represent our last marketing channel column. Let's go ahead and run all this, see what our final output looks like. Be careful with this. Notice that I'm still joining in my second join statement on the CS subquery, the original subquery that we created for current status. This needs to be updated to LMC, the alias we've given to the subquery we're joining on here, and so does this. Both of those need to point to the right subquery. So that's why we got a bunch of duplicates there. Let's try that again. Good. Now we're back to one row per lead. We've got our last marketing channel represented here. Now the question is, does this table we've just created match the same values as our snapshot table for January 2nd? So we actually just have that query right above here. We've already written it. Let's run these together so that we'll be able to compare side by side the output. The simple query against our snapshot table, and this more complex query against our slowly changing dimension table. We're hoping to see the same values. Okay, this first one is from our snapshot table where we filtered on January 2nd. We see for the first row, Sam shows not contacted, last marketing channel social media. Same thing in our slowly changing dimensional query. Second row, Brent at that point on the 2nd had been contacted, last marketing channel was social media. Same thing, contacted in social media. And Susan was not contacted, last marketing channel was organic search. Same thing on our query. So we've effectively replicated the snapshot date method with our slowly changing dimensional table. We had to write a lot more SQL code there. So that's your trade-off typically is, hey, you're gonna have less data being stored with your slowly changing dimension approach, but you're gonna have to write a little bit more SQL. So you might take this particular SQL and perhaps save it in a folder if you're referencing this and you're doing this quite often. That way, the next time you run into a situation where you need to use a slowly changing dimensional table, you've got the code right there and you can just kind of adapt it to the columns and the tables that you're using for that model build or that use case. Now, why did we do this in the first place? Well, remember the simple approach would have just been to, let's find our original table here, select star. I'll just go ahead and copy that. What if we just built our model on our leads table instead? What's the big deal? Well, let's run these last two queries together so we can compare the January 2nd snapshot to the current version. This second version down here is just the leads table. We would have been using this value that says Susan was converted. But on the second, when the prediction was being made, you can see she hadn't even been contacted yet. So that would be considered to be data leakage. Also, when we're looking at Brent's last marketing channel, if we just use the current table and the current value for last marketing channel, Brent would show paid search. But when we would have actually made the prediction, Brent's value for last marketing channel was social media. So we're able to capture this with this query we've written against a slowly changing dimensional table. And what that does is when you're training your model, it's more realistic of reality, so that when we train the model to get the optimized parameters and we apply it to everything we know as of today, we get a more realistic expectation of what's going to happen in the future. Now, whether you're using a slowly changing or a snapshot approach, it's important to make sure you know when those tables started being populated. If you're just creating these snapshot or slowly changing tables today, you won't be able to recreate snapshots prior to today. Now, you can still create feature variables based on transactional data, like sales as of a certain date, if you have a table that's transaction level. But you won't be able to recreate a categorical variable if you don't have a snapshot table or a slowly changing dimensional table. That's it for this video. I hope you find this information helpful, especially as you try to avoid data leakage in your data science models. If you did, consider liking the video and subscribing if you'd like to see more SQL and data science videos like this one in the future. Finally, please leave a comment if you have any questions about today's content, and I'll do my best to respond in a timely manner. Thanks again for watching, and I hope to see you in the next video.